Good morning, everyone. It's a pleasure to be here at OpenStack Day in Melbourne. My name is Tarso Dos Santos. Make sure I was spelling out correctly. You will understand. I'm from Veritas. I'm a technical account manager, and I've been working with high-performance computing distributed systems for quite a while. And now work with Veritas, been 4 months. Happily focusing on OpenStack. What we'll be talking on this session today is how Veritas is enabling OpenStack for the enterprise. But before I go ahead, just make sure you have a ticket because we're going to do a lucky draw for a coffee machine. Everybody has a ticket? Anyone doesn't have a ticket? Okay. And, well, actually the machine is not here. Because you may not want to carry the whole package. You're going to ship to you. So that's going to make life easier than take it home, because it could be quite big. But we've been hearing our community, we've been hearing our customers, what they're looking for OpenStack, and including the one of the last OpenStack day, that people are looking to have. And so we focus on the core projects of OpenStack, bringing more robustness and bringing more features to it. That's exactly what Veritas has been working for the last 3 years, actually, on this product. It's called HyperScale for OpenStack. The software-defined storage and data management solution for OpenStack. We talk a little bit, this is a business track. We're going to talk about a little bit of architecture, more the architecture than anything else, a little bit of product pitch, but how does that fit to the enterprise? Okay? But just before I go ahead and deep into the presentation, I just want to establish who Veritas is, because if you don't have enough gray hairs like I do have, you may not know who Veritas is. Veritas has been in the enterprise market and doing solutions, creating solutions for the enterprise for even before 1990s. We've been doing software-defined storage even before the term actually existed. We well known by net backup product for data protection, but we're doing interesting things with data around data, understanding what actually data you have, looking at how old the data has, how long hasn't been touched, and things like that, to try to achieve the nirvana of deletion. I think if you all know that it's very hard to delete data. So these tools actually help a lot. So how is that relevant to OpenStack? Is that we're bringing all this, we call this a 360 data management. We bring into this capability of enterprise into OpenStack. That's our aim. And we're starting with HyperScale. We know when organizations trying to adopt OpenStack for running their production workloads, they have to horizontally integrate with the whole IT ecosystem. Where is Active Directory? Where is data protection? So to make sure that there are no roadblocks to onboard new applications. That's exactly where Veritas has a lot of knowledge around the whole IT ecosystem. And the message here that our 360 data management, we're trying to bring all these features into OpenStack and make sure there are no roadblocks to adopt OpenStack in the enterprise and running production workloads. And we've been hearing about the hype of open public clouds, and organizations have realized now, and they're looking at, the questions are, can I run my mission critical workload? Because in the end, we're less tolerant for failure nowadays. If I can't access my pictures from my phone, I'll get mad. And that's our life today. So that's the first question. Is this platform agnostic? I think the last survey, 2017, has shown that it's very strong that people want to they do not want a vendor lock-in. And that's the play of software-defined everything, including software-defined storage. It's that easy to integrate. We know when onboarding an application, the hardest part is to get the business agreement to come on board so they don't push back, and make sure we have the compliance. We make sure we have all the tick boxes that the business require to come into on board in our platform. While we play in the infrastructure layer to make sure we have all those boxes ticked. and make sure we're agile by having all the tools to manage the whole stack. We're trying to make OpenStack simpler to manage. So therefore, you have the speed, reducing costs, and the scale that we're looking for. How do we deliver those promises that OpenStack are making? This is actually an old survey, 2016, because I did not have access to the 2017, I think. I couldn't find. But I saw a little change into, these are the business drivers, the main reasons why people are looking to adopt OpenStack. And this is a very good survey around the world to understand how people are using OpenStack. It's amazing, to be honest. I haven't seen that much detail in there. But 3 things: reduce cost, operational agility, and efficiency. So how quickly can we deploy applications instead of letting our business going out to the public cloud and finding a lot of pain sometimes. But what the things that our customers are telling us, and the enterprise side of things, looking at when they're trying to adopt OpenStack? What are the issues they find? They're finding hard to capitalize on the storage economy, having multiple redundant copies being created in the environment and bringing that resilience into the environment. How to get the performance they need, avoid that noisy neighbor when you have hundreds and thousands of VMs you have to manage, and how do you get some control of these environments and instead of creating islands of computes to handle that instead. And how to protect, how to give data protection and multiple line of defenses. And we're going to cover how we're achieving those topics, those desires, those issues. So therefore, 3 weeks ago, we made this product GA. It's software-defined storage and data management for OpenStack, focused on Cinder block. And the first release we've done is it's Ubuntu distribution. There's only for Ubuntu distribution for Canonical. And in the end of the year, we have a Red Hat distribution as well, and community-based distribution, and SUSE as well. So our focus is being flavor or agnostic in terms of distribution. So what the product is what we're trying to do, what we're trying to solve, is that, and what we're delivering. We bring the resilience and reduction of costs by looking at, if you have a tenant on application that you're bringing on board to OpenStack, we extended the way you can apply the SLAs into, looking from top to bottom, including how you do data management, number of copies you have in the environment. So we're achieving the reduction of costs and how to deal with hardware, and leveraging commodity hardware. So we're hardware agnostic, and we're software-defined storage. We bring quality of service from top to bottom to the environment to resolve the issue of the noisy neighbor. If you have a very critical application and you have these little guys that are coming and stealing resources, how do you manage all that? And not just in terms of CPU and memory, but how avoid stealing IOPS and storage resources from your environment. So that's critical for databases, for example, as we know. And bringing the data management into it, giving automatic pointing, some of those enterprise capabilities like point-in-time, crash-consistent point-in-time snapshots, and backup, zero backup window that you can run from this platform. And we're going to give a little bit of details, how does that work? But the use cases, what are the use cases that people have been experiencing with the hyperscale for OpenStack? We've been developing this product with our partners and customers. And the feedback that we've been having is that the ability, the features, they like it and they love it, and they are all related to the use cases, database as a service, because the ability to give that low latency capability. What we do, we manage direct attached storage. We work with direct attached storage. That's the fastest storage you can have, close to CPU, for example, and flash. Ability to provide quality of service, so you don't have all these high demanding databases stealing each other performance, able to coexist in the same environment. And dev tests with a point-in-time capabilities of creating point-in-time copies and crash consistence to give support environments and dev tests. How important it is to an application developer to spin up very quickly an environment, and we're giving that capability. And general computing, cloud computing with quality of services was a key as well. In the end, what they've been able to do is deploying a very effective sharing hosting capability without having to throw more hardware into the environment to patch some of the problems. So we looked at the existing software-defined storage architectures out there, and we thought we need to change some of the designs and bring this new capabilities into OpenStack. So if you look at some existing software-defined storage solutions out there, they focus in one single plane of compute and storage. Some of them, straight away, they make 3 copies of your data. For example, the red instance will have 2 extra copies in adjacent compute nodes. Straight away, 2/3 of your capacity is being taken away. So we thought we need to change this design. So reducing storage utilization and fixing the noisy neighbor problem. So what we've done, we detached the compute plane from the data plane. All the data services is done from the data plane. The compute plane, now you see the red instance, they don't have any more multiple copies of the compute plane, because on that layer we use direct attached storage and we apply quality of services. So it gives you the ability to pack 20 VMs in a compute if that's the compute that you need, because you use quality of services to accommodate all of them. So straight away you can have better compute utilization. So at the bottom layer, we use high density storage. So it gives a more cost-effective solution. What we've done is we clean the I/O paths. So we leave a high random IOPS and low latency applications running with your data in the compute lane, and you do the high stream storage capabilities at the data plane. So how does that work under the covers? We have a compute plane. We have a little instance running, the gray instance. It's got its full copy. So what we've done in OpenStack, you have your flavors. When you, as a cloud administrator, you have a VM, you have to deploy a VM, and you specify how much RAM and how much compute you need. Very easy to manage. However, we never had a data management persona to it. So we extend those flavors by allowing you to now define what's the minimum IOPS and the maximum IOPS, the number of copies and resiliencies that you need, and the reflection targets. The reflection targets actually are little deltas that they're making the writes safe across adjacent nodes. We did not want to rely on a data plane to give that response time for your application. So we're looking at giving very fast, low latency applications like database as a service, reason for those use cases. So those writes are quite small. They don't become a full copy. We specify as a tunnel parameter, and you specify, for example, 15 minutes. Every 15 minutes, we flash those writes into the data plane. From that point of view, you have point-in-time copies. The importance of this architecture is that you get point-in-time crash-consistent copies. Also, we're working on application consistency with Cassandra databases, for example, and across multiple nodes. It gives the ability to spin up environments from those point-in-time copies very quickly. You want to take a picture? Yeah, go for it. We have at the stand some brochures as well that describes very in detail. We call these the episodic data sinks. So we give that crash consistency. Today we have VSS as well for Windows APIs, so ability to extend those APIs to work with applications. So the importance of a quality of service is to fix that noise neighbor problem. If you think about it, for the cloud administrator, being a private cloud administrator, is how do you handle the quality of service? How can you imagine someone coming and start doing a lot of SQL statements, data analytics, when you're not expecting and hammering the system? You have to have tools to manage that. So ability to provide SLAs so you can straight away at the top with Horizon, without needing any tuning, specific tuning for file systems, be able to give and control that capability. And in case something goes through the cracks, you can still apply, and because it's all dynamic. And accelerated performance because we're using Flash at the compute layer. We have this smart I/O capability, which gives ability to, if you know that one, for example, database, that's 1 terabyte database, 10% of that data, it's only active. Ability to cache that data into a flash cache, like NVMe technology, for example. This is a case that quality of service supply is a little bit busy slide, but I'll try to make it easier to read, hopefully. We have a database called, with a flavor applied to it, it's Gold, and it's got 20K IOPS, and it's running very happily there. Everybody's having coffees, and everything is cool. Have an application with 10K IOPS, running cool, running very happily as well. But something happened in the middle, because the graph is going down. What happens is, those bronze guys, they do not have I/O limits on them. They are the SQL analytics that maybe came on board and start to really inquire the system using the resources. Remember, because everything is shared in OpenStack. And they start to bring down the performance for the more important, more resilient guys that you need to have more priorities. That's a classic example. When I used to be a cloud administrator, private cloud administrator, people, the end users would come to me and say, the web page is slow, the click is taking 30 seconds to respond. You used to go to the storage and see everything is taking, all the resources are taking. I had tools to look into the storage resource and think, oh, this VM is causing the trouble. The options is, I kill that VM, someone gets mad at me, or I'll find who actually is running that VM. And I actually ended up finding it was one of the reporting guys that were creating some reports. The application was sick, was launching SQL statements every 2 seconds. So it was consuming all the resources. What if I had the capability to just say, actually limit the number of IOPS these guys should consume and reestablish the performance? The importance of the data plane is to have multiple lines of defense for your OpenStack. By having those point-in-time copies every 15 minutes or as you want to tune it, you can give the capability to, one, provision new environments quickly, troubleshoot problems, and enable your DevOps capability inside your business. And give you that zero impact backup. What does that mean? Remember we talked about the data plane. We take backup from the data plane. All your applications are running on the compute plane, so they are not affected at all. So there's no more need to have your backup window during nighttime. You can take backups anytime, or you just use the point-in-time copies. And we're bringing this Veritas data management into OpenStack, and looking to integrate future tools like InfoMap, which gives the capability to look inside what the data is. For example, some of the database administrators, like I did as well, will do backups from the database, could be 2 terabyte files. And we keep them because we're doing patching, we're doing something about that, and we're just keeping another week, just in case we need something out of it. And suddenly you forget about them. So what happens with the environment, you have a lot of dormant data that's used in your environment, and now you have to throw more hardware in. So this tool actually goes through the metadata and tells you and gives a visual capability to see what data is, what type of files are. We have several capabilities in there. So we bring that technology into HyperScale, OpenStack. So this is a little bit visual of the importance of the point in time and ability to take the backups from the data plane. Today we integrate with NetBackup. It's out of the box. Everything is managed from Horizon. So straight away you give that capability to manage to the data management straight from Horizon. So that's the Horizon. That's the OpenStack management tool. So we look at the ability to make it OpenStack easier to manage. right? So that's our aim is here. You can see the compute plane at the top, the data plane at the top. These things are not available in other OpenStack distributions. In there, you have ability to see your point-in-time copies per VM, actually, and action on it. Instantiate new VMs from it, as well as doing backups and backup policies, and restore actually directly from OpenStack. So you don't need to go to your backup software to manage all this. You do everything from Horizon. And ability to have full visibility of your environment, looking at latencies, what components, how the components are performing, what VMs are performing. We've done a lot of work with Ceilometer and grabbing those statistics and making available for you. What we've been seeing out the market, a lot of people have done a lot of good scripts to get performance statistics, to graph all that data. So we bring that into Horizon to have that very, very quick view. All this to make it IT operations more agile. So what we've been doing with the community is that we've been working a lot with the community, developing new drivers that we had to attach to, working with easy to deploy with canonical distribution using the digital charm and the triple deployment tool for Red Hat. So we work in the community, learning a lot, we're sharing a lot of the code, and bring a robust continuous integration for Cinder driver. So I just want to leave to you, so that we're trying to bring the robustness to OpenStack, and we're doing it. We're trying to make OpenStack readily enabled for the enterprise. And we're focusing on bringing quality of service, the resilience and reduction of cost, and the data management around it. Well, thanks very much for listening to me. And one last thing, please visit our booth on the back. We have a lucky draw for a coffee machine. Now, I think everybody has a ticket. No, she doesn't have a ticket. Then. Do you have a ticket? Do you have a ticket?
No. Not fair for me to
Okay.
I have an espresso machine at 11.
Okay. I was going to use that machine here before we start my session to make you awake. But we have another person there. But if you have any questions, I think that's how many minutes I do have?
You have 3 minutes.
3 minutes, so just a question. If anyone wants to ask any questions?
So I'm just trying to get your head around the Veritas product itself. So this is a plugin to Horizon that talks to the rest of the OpenStack environment? Is that correct?
Yeah, it is a whole complete implementation includes the Horizon framework, changes that we had to do, Cinder driver, Nova, filters, and I had actually had a slide which had how does that integrate. So, but for example, install Canonical, and then we install HyperScale on top of it.
Okay, so it's an
Overlay, yeah. And yeah, we attach and then load the new drives, new capabilities. We brought a little bit of change, bring more robustness to it, and add our capability to grab that. Yeah, extra fields and so on. Yeah.
Okay,
Any other question? Yeah. End of the year. We've been working with Red Hat for quite a long time, but there was some code discussions that the community wasn't happy, so we went back and changed things. So we're working very heavily with the community. So Red Hat in the end of the year, Suze, Mirantes, I think actually as well. And yeah. Anything else? Anyone else? No? All good? Okay.
Close your eyes.
All right. E6. I think he deserves. He asked the questions. Yeah, that's right. Okay, so I'll hold that
You hold
because I
that
think.
one.
Yeah, thanks. Thank you very much.